Hello and welcome to Physical Geography. I am Brian Krause and I am going to be your instructor for this semester. And today we're going to take a look at part one of chapter one. I've kind of divided chapter one into two sections, so you'll have two PowerPoints for this chapter. And I'm going to introduce concepts about the study of the Earth and referencing the Earth's surface. So in this mini lecture, like all the mini lectures that are to come, I'm not going to cover all topics or ideas that are presented in your text. Rather, my aim is to highlight a few of these key ideas and kind of discuss them in a little bit more detail. But you will be responsible for other parts that are in your text that I'm not going to be covering in this PowerPoint. And those things that you're responsible for are outlined in the chapter outline that you'll find on Blackboard. So in this PowerPoint lecture, I've also included some non-graded quiz concept checks. And so when you get to these quiz slides, which are at the end of the PowerPoint, you can right-click the mouse and select pause, and this will allow you to pause the narrated PowerPoint, and this will allow you time to answer the question. And once you've decided on the answer, you then can right-click the mouse again and select resume, and this will start the PowerPoint, and then the following slide will provide you with the correct answer and an explanation of why that's the correct answer. As well as you can kind of pause this PowerPoint at any time during the presentation, and then once again just right-click and say resume. So on that note, let's dive right into chapter one. So the question is, what is geography? And geography, in a simple definition, is the study of what is where and why is it there. So for example, why are there a bunch of tornadoes in the Midwest, and why don't we have any tornadoes here in Idaho? Why do we have volcanoes forming in some areas and we don't have any volcanoes in other areas? Why does California have a bunch of earthquakes and Idaho does not? Why do we see certain types of rock formations in Utah and we don't have those same kind of rock formations here in Idaho? So those are the kind of the questions that geography, especially physical geography, likes to look at and kind of come up with answers. And you'll see this what is where and why is it there repeatedly through your text in these PowerPoints. So what is physical geography? So the discipline of geography is divided into two main branches. There's physical geography and there's cultural geography. And I also teach a cultural geography class as well, which is Geography 102. And cultural geography studies the world, its people, communities, and cultures with an emphasis on relationships across space and place, where physical geography deals with the study of processes and patterns in a natural environment, like those we'll talk about coming up here in the lithosphere, the atmosphere, the hydrosphere, and the biosphere. So your text refers to these environmental spheres. So let's turn our attention to kind of looking at these spheres as a quick introduction to physical geography. So here we're going to look at the environmental spheres. And the Earth is this system that is a collection of four interdependent parts, or called spheres, as your book refers to them. And interdependent means that they're all related, that if you change one, it's going to have some kind of effect on the other sphere or more than one sphere. And so these Earth spheres include the lithosphere, the atmosphere, hydrosphere, and the biosphere. So the lithosphere describes the solid inorganic portion of the Earth. It's composed of rocks, minerals, and elements, and it can be regarded as the crust and the uppermost mantle of the Earth. And your text has an image of exactly what it covers there. The atmosphere is this gaseous envelope that surrounds the Earth, and the atmosphere is divided into the troposphere, the stratosphere, the mesosphere, and the thermosphere. And we'll get into greater detail in later chapters on that. The hydrosphere is composed of all water on or near the Earth. And so it's going to include the atmosphere, oceans, lakes, rivers, soils, glaciers, and groundwater. And the water can move from one store to another by the way of evaporation, transpiration, condensation, runoff, precipitation, infiltration, and groundwater flow. And the last one here is the biosphere, and it encompasses all parts of the Earth where living organisms can exist. So the biosphere extends to the upper area of the atmosphere where birds and insects can be found. It also reaches kind of deep down underground into caves at the bottom of the ocean like these hydrothermal vents where this hot water comes up and animals live by this nice hot water. And the biosphere extends to places that life of any kind can exist on the Earth. So in these that I just covered, these 4 spheres, I'm not going to have a lecture on the hydrosphere or the biosphere, but you will be covering those in your physical geography journals. So you'll have to read that chapter, or those 2 chapters as well. So it's important to understand that these 4 spheres are while individual, they will also study in more detail in the coming chapters, but it's equally important to understand that they are not this discrete and separate entities, as I mentioned earlier, that they're closely related and interconnected. So for example, like a change in the atmosphere can have effects on the hydrosphere and the biosphere. So just kind of think of an example. If we're changing the atmosphere, the different types of gas molecules that are in the atmosphere, how is that going to change other parts, the hydrosphere, the biosphere, or the lithosphere? And we will get into more detail on that as we move along in the course. So next is kind of looking at the shape of the Earth. So looking at this diagram here, you will note that the diameter to the Earth's equator is slightly longer than it is from the poles, from North Pole to South Pole. So why do you think this is? Why does the Earth kind of bulge along the equator? Well, it's due to the Earth's rotating. So as the Earth rotates around, this force of it rotating around is kind of stretching out the Earth ever so slightly, kind of giving it a little bulge around the equator. Therefore, the Earth is not this spherical in shape, or it's not a perfect circle, it's not round, but more accurately described as this oblate spheroid. So it's certainly not round. The next thing that we'll talk about here, and your book discusses, are great circles and small circles. So any plane that passes through the center of the Earth and divides the Earth into 2 equal parts, and that's key, it has to be 2 equal parts, is a great circle. And this is illustrated in figure A in the upper left corner. So a great circle that connects 2 points is always going to be the shortest route between those 2 points. Because this is the shortest route, great circles are often used by ships and aircraft when currents and winds are not a significant factor. So this is shown in the bottom diagram, which is an airline route between San Francisco and Tokyo. So you can see when we're heading east, the fastest route is not the Great Circle, but it's actually a different path where it's following the jet stream. That jet stream can significantly reduce the time. So anybody who's flown from the West Coast, for example, to the East Coast knows that the time going from the West Coast to the East Coast is much faster generally than going from the East Coast to the West Coast, and that's because of the jet stream. But also you can look at going from the East Coast to the West Coast. They're following the Great Circle because that's going to be the shortest route. So a plane that passes through any other part of the Earth other than the center is called a small circle. So that's an example in figure B, in the upper right corner, where it is not equally divided into 2 parts of the Earth. And that's a small circle. So the next thing we want to be concerned about is how are we going to find or reference places on the Earth? So we need some way to do that. And the first way, or part of the way, is called something called a latitude. So latitude is also referred to as a parallel because they're parallel to one another. And they are angular measurements of distance north or south of the equator. And we can see this in the diagram on this slide where an imaginary line is drawn from the center of the Earth to the Earth's surface at 10, 20, 30, and 40 degrees, which is shown there. So first you have the red line, which is showing you the equator, and then they have these imaginary lines going from the center of the Earth and out. You can see that it goes to 10, 20, 30, and 40 on the right-hand side going north. So, and then you can also see the lines going of latitude going south, 10, 20, and so forth. And they both, whether you're going north or south, will end at 90 degrees north or south, depending on the direction. And as you'll notice there, they're also called parallels because each one of those lines is parallel to the other line. So that's why they're called parallels. So there are several more important zones of latitude that we'll look at in the next. Your textbook outlines 7 latitudes that are important and that you should know. And they are the North Pole at 90 degrees north, Arctic Circle at 66.5 north, Tropic of Cancer at 23.5 degrees north, the equator, Tropic of Capricorn at 23.5 degrees south, and the Antarctic Circle at 66.5 degrees south, and the South Pole at 90 degrees south. So the natural environments differ dramatically from the equator to the poles, for example. So why is the environment so much different at the North Pole than it is at the equator? Why do you think this? What do you think accounts for this difference? Well, these differences are a kind of result of the amount of solar energy that's received, which is greatly varied between latitudes and the seasons of the year. So the equator can receive 12 hours of sunlight and 12 hours of darkness, where the North Pole, for example, depending on the time of year, can receive 24 hours of light and 24 hours of darkness. So as you can see, this is going to greatly affect the environment. And we'll take a closer look at this in the next lecture. On page 12 of your text, there are 7 descriptive zones, or bands as they're also called, that you should know. Longitude, which are also called meridians, are these angular measurements of distance east and west of the prime meridian, which is outlined in the red meridian there, or longitude. And longitude values range from 0 degrees and go to 180 degrees. And lines of longitude, you'll notice, converge at the poles. So the distances between them vary, with the greatest distance at the equator and becoming increasingly closer and converging at the poles. So as you can see, like the parallels were called parallel because they were parallel to each other. But these are certainly not parallel since they vary in width and converge at the north and south pole. So here on this slide we have the geographic grid. So on the left-hand side we have the latitude, and the center one, B, is the longitude. And if you combine the latitude and longitude lines to create something called the geographic grid or reticule. And this reticule allows you to reference certain places on the Earth's surface. So for example, if you want to know the latitude and longitude of a plane crash, or the latitude and longitude of Mount Everest, or the latitude and longitude of your house, you can now do that using the reticule. So that concludes the first part of Chapter 1. The following slides here, I have various questions for you to test your knowledge on what we've covered so far. And these are a good representative sample of what will be on, or it's to be expected from a course. So that concludes the first part of Chapter 1. The following slides here, I have various questions for you to test your knowledge on what we've covered so far. And these are a good representative sample of what will be on, or it's to be expected from a quiz. These exact questions will not necessarily be on the quiz, but questions quite similar to these will be. So if you do well on this and you understand these questions, you should do well on the quiz. See you at the next lecture.